All right, 3, 4 is what we're up to here, exponential and logarithmic equations. Okay, so we're going to use our properties to either cancel out or add in some logs and some e's and things like that, and we're going to try to get x all by itself. So we're just solving for x in this chapter, but these problems have logarithms and exponents in them. All right, so we want to remember these properties, the one-to-one. If we've got a and a, we can cancel them out, so x equals y. And same thing here, if we've got log a and log a, we can also cancel and have x equals y. Same thing with the inverse, right? A to the log of a is going to cancel, leave us with x. Log a of a with x as the exponent just leaves us with x. So we want to remember these four. We're going to use them in these problems. Okay, so a couple examples. If we have 2 to the x equals 32, remember we could rewrite 32 as 2 to the 5th. And then using the one-to-one property, we get to write x equals 5 because we cancel out the 2's. Same thing for these problems. If we have them on the same side, though, we could move natural log of 3 to the other side. Then we could cancel and just get x equals 3. If we don't have the same base, but we could move them around so we get the same base, we want to do that. 1/3 is the same as 3 to the negative x. And then 9 is the same as 3 squared. Cancel the 3's. We've got negative x is 2, x is negative 2. All right, so that's the one-to-one. We can also use the inverse. So if we ever have an e, what cancels that out? Natural log would. But if we add natural log to the left, we've got to add it to the right. So now we have natural log of e, that's going to cancel. We'll just have x. Natural log of 7 doesn't cancel, so x is the natural log of 7. See the same thing here. How do we get rid of natural log? We do e to the natural log. But if we do it on the left, we have to do it on the right. E to the negative 3. So e to the natural log cancels out. We're left with x. And on the right, we've got e to the negative 3. All right, same rules apply. If we've got base 10 here, we would use 10 to the log base 10. If we do it on the left, we have to do it on the right. So we'd end up with x is 10 to the negative 1, or x is 1/10. And then how do we get rid of log base 3? It would be 3 to the log base 3. Got to do that to the other side as well, so 3 to the 4th. So we would get x equals 3 to the 4th. 3 times 3 times 3 times 3 is 81. All right, so either use the one-to-one or the inverse properties to see if you can do this problem. Number 17. Solve for x. All right, so a couple of strategies here for solving these problems. First, rewrite the original equation in a form that allows you to use either one-to-ones or the inverse, right? Rewrite exponents in log form and apply the inverse property, right? We saw that on these problems here. Or rewrite log problems in exponent form and apply the inverse, all right? So on all these problems, we're either doing one-to-one or doing inverse. Okay, somehow we just got to apply it correctly. Let's see if we can do it. All right, so a couple of problems here. E to the negative x squared equals e to the negative 3x minus 4. All right, so this one's one-to-one. We get to cancel our e's. So negative x squared equals negative 3x minus 4. I've seen a lot of people forget all about doing quadratics. Let's get 0 on one side, minus 3x minus 4. And we've got 0 equals what multiplies to 4 and subtracts to 3. X minus 4, x plus 1. So x is 4, or x is negative 1 on that one. Okay, second problem, we're going to, first of all, we're trying to get the x by itself, so we're going to divide by 3 first. Okay. So now we've got 2 to the x equals 42 divided by 3. You end up with 10 plus 4, 14. All right, I believe that's correct. Yes. All right, so now how do we get this x down all by itself, right? To cancel out base 2, we're going to add in a log base 2. So now the 2's would cancel. But you can't just do it magically on one side without also doing it on the other side. Let me get this out of the way. So now we must equal log base 2 of 14. So now we have x equals log base 2 of 14. And if you had to plug it into your calculator, we could always do change of base, log 14 divided by log 2. And if you plug that in correctly, you end up with about 3.807. 3 decimal places. All right, go ahead and see if you can do problem 29, solve for x. Okay, example 3, let's get x by itself. So we're going to move the 5 over. We've got e to the x equals 55. The way we cancel out e is by putting a natural log in front of it. So x equals the natural log of 55. We're going to punch that into our calculator, and the natural log of 55 is approximately 4.007. All right, so same thinking. Try problem 55. All right, example 4. We want to find t by itself here, so we're going to try to get the parentheses by itself first. So we'll add the 4. We've got 2, 3 to the 2t minus 5 equals 15. Let's divide it by 2. So now we've got 3, 2t minus 5 equals 7.5. How the heck would we get rid of the 3? Log base 3. Got to do it to both sides, so this will end up being log base 3 of 7.5. All right, so these cancel. We've got 2t minus 5 equal to the log base 3 of 7.5. That's going to come out as a decimal. Okay, so to get t all by itself, we're going to plug this into our calculator, add 5 and divide by 2, so t will be log base 3 of 7.5, whatever that turns out to be, plus 5, this is all by itself, right, divided by 2, and if you do that properly, the answer in the book turns out to be 3.417. Right, getting t by itself by canceling out 3 with a log base 3. All right, so see if you can get 57, trying to get x all by itself. All right, so now let's look at this one. This is a little tricky here, but one twist here, it's going to be exponential because of this. E to the 2x, our rules of exponents, we could always do this. E to the x squared, pull it on the outside, right? Because the rule says that we're just going to times the 2 times the x. So now minus 3e to the x plus 2 equals 0. So now we've got a quadratic. This is the same as saying x squared minus 3x plus 2. Is there a way to factor that? How do we multiply to 2 and add to 3? All right, so it's just going to be e to the x. We're going to have minus 1 and e to the x minus 2. This isn't what it actually is. This is just an example of how we would factor it. All right, so that equals 0. So e to the x equals 1. E to the x equals 2. We're going to put a natural log in front of everything. So x equals the natural log of 1. X equals the natural log of 2. If you put the natural log of 2 into the calculator, what pops out is 0.693. And you shouldn't have to use the calculator for the natural log of 1 because anything, any log of 1 turns into 0 because e to the 0 or anything to the 0 turns into 1. So there's our 2 solutions. All right, so same exact thinking. See if you can figure out 59. Factor it. All right, example 6, a couple quick solving equations here. We want to get x by itself, so we're going to say e to the. That's how we cancel out natural log going the other way. So x equals e squared. And we can leave it just like that. Problem B, we've got a 1-to-1. Cancel them out. 5x minus 1 equals x plus 7. So 4x equals 8. So x equals 2. And the last one here, let's clean this up first. Don't have a 1-to-1 yet because we need to clean up the left and make it log of 3x plus 14, sorry, log base 6, 3x plus 14 over 5, right? We're going to condense it, equals log base 6 of 2x. Now we can cancel them. So we've got 3x plus 14 over 5 equals 2x. Let's times both sides by 5, so 3x plus 14 equals 10x, 14 equals 7x, 2 equals x. Okay, if we follow the algebra all the way through. Your turn, 83, you get x by itself. All right, example 7. Again, trying to just get x by itself like we are on all of these. We're going to subtract, sorry, 1. Subtract 5 and get -1. So 2 natural log of x is -1. Natural log of x is -1/2. How do we get rid of the natural log? We're going to go e to the. So we're going to have x equals e to the -1/2. And you're going to throw that into your calculator, and the number that pops up is 0.607. Rounded to 3 decimal places. Same thinking. Do 93. All right, so again, trying to get x by itself. Divide by 2 first. Log 5 3x equals 2. All right, so before we got rid of natural log by having e as our base, but now we want to get rid of log 5, so we're going to have 5 as our base. Those will cancel. We'll have 3x equals 5 squared. So 3x equals 25. So x equals 25 over 3. All right, so cancel out logs by using a base of the same number. Get 97. See if you can get x by itself. All right, so let's check for some extraneous solutions here. So on this problem, we can combine our logs. We're going to have 5x, x minus 1 equals 2. Let's get rid of our log. Remember, it's base 10. So we'll have 10 and 10. So now I've got 5x, x minus 1 equals 100. And now we're going to deal with a quadratic. This is 5x squared, just distributing, minus 5x. I'm going to minus the 100 and get 0. Let's factor out a 5. X squared minus x minus 20. How do we multiply to 20 and subtract to 1? 5 and 4. So x equals 5 or -4. Okay, so now extraneous solutions. You cannot do logs of negative numbers. Remember our graph of logarithms? X has got to be greater than 0. The thing in here has got to be greater than 0. Okay, so let's check it. 5 minus 1, is that greater than 0? Yeah, no problem. But if we plug -4 back in, -4 is not greater than 0. We can't use -4 because we cannot do logs of negative numbers. So if we plug -4 in for x, we'd end up doing the log of -5, and that is not allowed. So -4 is an extraneous solution. Can't use it. See if you can find the extraneous solution on problem 109. All right, last 2 examples here. I know there's a lot going on here in 3-4. You've deposited $500 in an account that pays 6.75% interest compounded continuously. How long will it take for your money to double? All right, so this is PERT. And so now we know that we start with $500. E to the 0.0675. And we're trying to figure out the time it'll take our money to double. So if we start with 500, we're going to end with 1,000. Let's solve for t. All right, so we can divide here. And we're going to get 2, which should make sense if we're thinking about our numbers should be doubling. 0.0675t. How do we cancel out e? Let's throw a natural log in front of it. So the natural log of 2 equals 0.0675t. we could divide both sides by 0.0675. And we'll end up with t approximately equal to, we've got to plug that into our calculator, but if you do it correctly, you're going to end up with 10.27. So it's going to take you about 10 years for your money to double. All right, same type of problem on 117. All right, last one, here we go. Retail sales in billions of e-commerce companies from 2002 to 2007 can be modeled by y equals, gives us the equation, where t represents the year, with t equals 12 corresponding to 2012. Okay? During which year did the sales reach 108 billion? So sales is y, so let's plug 108 in here. And we're solving for t. 0.7 natural log of t. All right, first thing we're going to do is add 549. So 549 plus 108 is going to be 657 equals 236.7 natural log of t. And if we divide both sides by 236.7, we're going to end up with, let's see, I'll get it on my calculator. .776 natural log of t. All right, how do we get rid of the natural log? We've got to raise it from the base of e. So e to the 2.776 turns out to be 16.049. That's t. So in the 16th year, we did this. Remember, year 12 is 2002, so year 16 must be 2006. 2006 would be our final answer. All right, so last one for you guys to try. Problem 133. Good luck. Make sure you're noting down any questions you have. We'll go over it in class.